Hey Bridge class, this is Mrs. Krupstat, and this is just going to be a quick, hopefully 5-minute video on a review of slope and some things that you might want to know or might need to know going forward in algebra. So first, slope, it can be written or understood a whole bunch of different ways. The first way, which I have mentioned in class because I like the little chant, slope is fun, rise over run. And the rise is like our up and down, and our run is our side to side. And so that kind of brings us into the second representation of slope, which is the equation for slope. It's kind of that one that you probably would see if you Googled how to find slope. Y2 minus y1 over x2 minus x1, and it's y because y is the axis that goes up and down, which corresponds to your rise, and x is the axis that goes side to side, which corresponds to your run. Now, this equation might seem weird because it's like, well, where do the y1 and y2 come from? We usually use this equation when we are finding the slope between 2 points. Okay, so we would just have one point that is x1, y1, and one point that is x2, y2. Then the third way we want to think about slope is just the change in y over the change in x. And again, that's going back to the fact that y is that vertical axis and x is the horizontal. So we're going to do 4 different examples of how to find slope. The first is from a table, and you can follow along with your note sheet and take notes on this. This is probably the most common way that we have done it in class or in your algebra class up until now. And in this case, we want to think about the change in y over the change in x. And just because that's probably the fastest way to do it. You could do it other ways, but this is the fastest. So the change in y, I am going to be looking at what is happening to my y's as I go along in this table. Well, to get from 9 to 12, I add 3. 12 to 15, I'm adding 3, and so on and so forth. So this is a linear pattern because the difference between the y's remains the same every single time. That would be my change in y. 3. The change in x comes from what is happening to the x values as we go along in this table. So to go from 3 to 1, we're subtracting 2. Then to go from 1 to -1, subtracting 2, so on and so forth. So our change in x is -2. So this would be one way to write your slope. And usually we leave slope as a fraction. I talked in my class the other day that 3 over -2 is the same thing as -3 over 2, which is the same thing as -3 over 2. So you could really write this any which way you wanted to. Especially if you were graphing it and you wanted one way versus the other. So in this next method of finding slope, we have 2 points. In order to find the slope given 2 points, we are usually going to be using that formula for slope that I gave in the beginning, where we're just subtracting our y's and subtracting our x's. Remember, y's always go in the top. In an ordered pair, the first part of your point is always x. So I'll call one of them x1 and one of them x2. And the second part is always your y. So I'm going to put my y1 first and my y2 second. And we just want to make sure that the x1s and the y1s stay together and the x2 and the y2 stay together. So then when I'm plugging into this equation, I always like to put my minus signs in first because that allows me to just plop in the numbers. So in this y2 spot, I'm going to put 10. And in my y1 spot, I'm going to put 6. Then in my x2 spot on the bottom of the denominator, I'm going to put 8. And in my x1 spot in my denominator, I'm going to put 3. Then it's just as simple as actually doing the subtraction. 10 minus 6 is 4. 8 minus 3 is 5. And that would be the slope between those 2 points. Here is our next option. This is from an equation, and this goes back to what you talked about in class yesterday. Our equation of a line that we are mostly going to work with is y equals mx plus b. in this equation, there are two parts. We have the m and we have the b. Really, you need to know what the difference between those are. M is your slope, and b is your y-intercept. Okay? So if you have it written in this form, and note, this form has y all by itself, okay, that number in front of x is always going to be our slope. So in this case, the number in front of x is 7, so our slope is 7. And then last type would be from a graph. From a graph, we're going to again rely upon that fact that slope is rise over run. Rise is how far up and down we go. Run is how far right and left we go. And we can even break it down a little bit more. Up is going to be in the positive direction. Down is going to be in the negative direction. Right is in the positive direction, and left is in the negative direction. So when we move on this graph, that's going to help us, because I want to go from one point to the other. Okay, I'm going to start at the bottom point, and I'm going to go up 1. So if I go up, that's a positive direction, and then I'm going to go to the right 3, and to the right is a positive direction. So my rise is a positive 1, and my run is a positive 3, so 1/3 is my slope. If you're thinking, well, gosh, what if I wanted to go another way? I could start at that top point and go down 1, which would be a negative 1, and to the left 3, which would be a negative 3. So my rise is negative 1, and my run is negative 3. A negative divided by a negative is a positive, so that ends up giving us the exact same answer. If you didn't like any of the points, or if their points were not given on the line, you just want to find a nice point that is somewhere on the line and crossing one of these nice little corners. You can really use any nice point on the line in order to count rise over run. Well, that's it, you guys. Your job today is to practice some of these skills, and I have a worksheet with, I think, about 12 problems on it, about 2 to 3 of each of these, so that you can master slope and take it into your intermediate algebra classes. Have a great day.